Over the last 2 winters, we've seen hundreds of agricultural buildings collapse under the weight of snow. There are 3 principal reasons for this. Some buildings have passed their use-by date. Other buildings have had more snow than they could originally have been designed for. And in buildings like the one we're standing in, they have been poorly designed. This is a new building. It's 27 metres span, 36 metres long. It hasn't even had an animal in it. In fact, the builder was very close to completing the building at the time of the collapse. It isn't an S&A building, nor were the manufacturers of the building RIDBA members. My involvement is to rebuild the building to the correct standards. We're producing this DVD to show farmers some of the reasons why this building will have failed, so that they will be better informed when they buy their next building. First of all, let's hear from the farmer, David Hurren.
My name's David Hurren. We farm at Borough Green Farm, Low Easby, Great Ayton, on the outskirts of Middlesbrough. We farm a 75 cow herd. We plan to expand the herd with the investment of a milking robot. We got quotes in roughly January 2009. We got 3 different quotes. All the quotes were roughly the same price. We got different feedback from different companies and felt that the people that we decided to go with was the middle quote, and we felt, as they had all quoted a British standard, we felt that this British standard would be the same for every company. The British standard that was quoted was 5502, and we felt this was enough protection for us to give us the type of building that we felt was necessary for the span of building, which was a large building, 90-foot span. The building was erected starting April 2009. The company that we went with were a kit building company, so they supplied the building and we used a local firm to erect the building. The work started roughly about April and the building was completed about May, June of 2009. Although we finished the building in the summer of 2009, we hadn't actually finalised our layout plans and we decided to leave the internal work until spring 2010. 2010 came, spring, I do quite a bit of off-farm work and we found that we didn't have the time to actually complete the work, and we didn't actually make a start till August 2010. Unfortunately, the snow started in about the last week of November. The snow was not unusual in terms of volume, but was unusual at the time of year. It came much earlier than we normally get snow. Unfortunately, on the 2nd December, without warning, the building actually collapsed. The building actually collapsed at 3 o'clock in the afternoon. Roughly 20 minutes to half an hour before that, myself and Daniel, who helps me, were actually in the building at the time. We just walked out and Daniel was actually in the feed passage when the building collapsed. Couldn't believe it. It was unbelievably frightening. It was instant, no warning, no creaking or groaning. It was instant. The building just came straight down. Fortunately, there was no cows in the building. We had planned to put the cows in roughly Christmas Eve, ready for training to go into the robot roughly 2 to 3 weeks later. If the cows had been in, the situation would have been so much worse and so much more upsetting than it was already. Obviously, we've had our insurance company have been out to assess the damage. They've sent an independent engineer who feels that the building failed at the haunches. The detailing around the haunch area wasn't good enough, and actually that the building wasn't fit for purpose. And that is the reason the building came down. He did a measurement of approximately 460 mil of snow on the roof, but felt a building of this size should be able to stand that volume of snow on it.
So, why did this building collapse? Let's have a walk around and have a look. A contributory factor to the collapse of this building is the fact that the bottom flange of the rafter hasn't been restrained. This allows the flange to twist under loading. It would have been very easy to have positioned struts between the purlin and the bottom flange on both sides of the rafter. This would have significantly increased the stability of the building. This is a good example of how a large agricultural building would be. From this vantage point, we can clearly see the effects of not having a gusset between the inner and outer flange of the column. The deformation being the result of the additional snow load collapsing the building. In addition, this column is too small, albeit 400 millimeters, it's a big piece of steel. It is too small for a building of this size. As a consequence of the building collapsing, the humble foundation is put under considerable strain, and we can see the effects of the column turning the foundation out of the ground. This is another weakness in the design of this building. This is a 225 deep purlin and would usually have a connection of two 12mm bolts. Here we can see these bolts have sheared off in this section of roof that's on the floor, and these are 10mm single fixings, clearly inadequate to comply with design. Although not a contributory factor to the collapse of this building, the roof bracings are only 60mm in diameter. The one that's in shot at the moment is clearly seen to be sagging, and these are unsuitable for this particular building. The building that we've just been looking at has failed for a variety of reasons that we've explained. There have also been other buildings that have failed during the last 2 winters, some with foundations that have failed, or the connectivity to the foundations, others where the connections of the steelwork have failed with bolts shearing. Other buildings have been constructed with the bays too large, and as a consequence the roof has collapsed. Agricultural buildings should generally be designed to the British standard BS 5502. Here we have Terry Walker, who is S&A Fabrication's structural engineer, and he will point out some of the good aspects of steelwork design and how that links back to the British standard.
The farmer thought he was safe choosing a quote claimed to be to 5502. Clearly it was not, otherwise it should not have collapsed given the snow loading that was applied to it. BS 5502 is the agricultural standard. It gives you all requirements to design an agricultural building. It also refers you to the other necessary standards within that code to be used in the design of the structure. Not all buildings need to be built to 5502, although it is a good idea to do so because at least you get something to a British standard that you can rely on. Some fabricators decide not to do so and are at risk. Claiming to fabricate to 5502 is a fraudulent standard if you do not adhere to it. In my opinion, a building of this nature should not have collapsed given the snow load that was applied to it in this case. Had we designed the structure, we would have incorporated the following aspects. The rafter bracing coincides with the top of the gable post. It's taken down through symmetry to the column head, where it's then picked up by the vertical bracing system which carries it down to the foundations. Restraint is provided to the underside of the rafter. Torsional restraints, these are clearly seen as indicated, and a torsional restraint to the bottom of the haunch is shown as indicated here. A longitudinal plate stops the thrust from the haunch, crippling the column at this point. This can clearly be seen in this photograph here. Foundations should be designed specifically for the ground conditions and not generically for any building. Further consideration should be given to when placing a smaller building at a lower level adjacent to a larger building. Snow build-up on the roof can lead to substantial deformation of the new building, extra loading to the existing foundations and possible failure to the purlins. But what you cannot see on this particular photograph is the fact that the smaller building had collapsed internally.
So in conclusion, what would be our advice? Firstly, I think it's a very good idea to use a RIDBA approved contractor. RIDBA stands for Rural Industrial Design and Building Association, And there you've got a body that oversees the industry and a body that you can trust. Number 2, take references from existing customers and preferably go to visit the manufacturer's factory and assess the company that you will be dealing with. 3, ask the contractor to take you to see similar buildings, preferably in similar locations, and take note whether the stiffeners and restraints we described earlier are in place. 4, don't be frightened to ask for structural engineers' calculations. These will demonstrate whether the building has been properly designed. Now, there may be a small additional charge for this, but when you consider the investment that you're making, this may be peanuts compared with a collapsed building. During 2010, over 4,000 agricultural buildings collapsed under the weight of snow. This is a huge loss to agriculture and to the insurance industry. Not only are we talking about the capital cost of the buildings, but also the loss of animals and the injury of animals. Fortunately, to the best of our knowledge, there hasn't been a human fatality. As a salutary reminder to how close we have been to a loss of human life, I want to show you one more photograph. This building had the rafter bolts shear. The farmer's daughter was in the building with her pony when the roof fell in without warning. You can see her riding hat amongst the debris. Mr. Heron and his farm worker also had a very narrow escape. Please don't leave your building design to chance.
My message would be to farmers to look closely at the quotes that you've got, look into more detail on the British standard, ideally use a company who is a member of a RIDBA, who will give the backing and clarification on the sort of company that you're actually going to be dealing with. I got 3 quotes, felt that they were all equal quotes, but clearly they weren't, and we've been caught out.